This question is called cubic of integer. It says let x be an integer between 1 and 10 to the power of 12. What is the probability that the cubic of x ends with 11? We have an important hint that says the last two digits of x cubed only depend on the last two digits of x. Now that means that if we have this x value that has like some numbers like 1, 5, 0, 5, 6, 4, 3, 4, like a, b, and we can call this like y, like these two, this last portion we can call it y. That's all we care about. This is what impacts our result. So if we have y equals 10a plus b, because if we have a's, if let's say the last two are 5, 5, that means a is equal to 5, b is equal to 5. Then if we plug that into here, 10a, which is 50, plus 5 is equal to 55. So that's like, we can represent the last two digits here as this variable right here. So we can forget about x now. So all we care about is y. So now our question can become like, oh, like yb, right? And let y, same thing. So if we have y cubed, that's equal to 10a plus b whole thing cubed. If we expand that out with the binomial theorem or just manually, we get 1000 a cubed plus 300 a squared b plus 30a b squared plus b cubed. Now if this is our whole term but expanded out among several different terms, this is our whole our whole cube result, right? And we're gonna expand this out where this is broken up. As you can see, this term represents the thousands place, because if we have like some a is equal to like 5, then times 1,000 will be like, or let's say a is equal to 2. A cubed is 8 times 1,000 is 8,000. So whatever this term ends up becoming, this portion of it represents what our thousands place is, right? Same goes for the hundreds place and the tens place. So the thousands place, hundreds, tenth, and this is our singular portion. This is like the one digit. This portion represents our last digit, the ones place. Now, b cubed, we need that ones place to equal 1. Okay? And what value does that for us? That value that does that for us is 1, right? B cubed is equal to 1, so b is equal to 1. So we need, from y equals 10a plus b, that b has to be a 1. Cool. Now we have what impacts our tens place is 30a b squared. And we have that b is equal to 1. So we need that 30a to end in 10. We can also say that we need 3a so to end in 10, because we have to end in 11 overall, right? We need the tens place to end in 10, and we need the ones place to end in 1. We already got what b value helps us to get that ones place to end in 1. Now we have to see what value of a gets us a number where the last two digits are 1, 0. Or we can say the last digit is 1. If you just divide it by 10, right, as we're doing here. So we're saying 3a to end in 1. Okay? If a is from 0 to 9, let's just say for now, we can also say like other terms, but we can start off with 0 to 9 because it'll help us conceptualize what value of a can start us off. We can see that if you go from like 0 to 9, the only value times 3 that will get us a result that ends in 1 is 7. 7 times 3 is 21, and none of the other terms will do that for us. Okay? Yeah. So if same thing, it's like 17 times 3, 1, 2, 51, right? So we need that last term to be a 7. So we need a to equal 7. So even if we're not bounded by 0 to 9, we have, no matter what the value of a is, the last part of it has to be a 7. Okay, so now we have a is equal to 7, and we had b is already equal to 1, and we know that y is equal to 10a plus b. We can plug that in as 71, right? So it asked what the probability of getting this value was. So it's very simple. Out of every 100 terms, one of them will end in 71. So 1 out of 100 terms will end in 71. And that's the answer. 1% if you need. It's a little tricky, and I don't think this question will appear much in interviews or even exams. I don't know. This question is pretty out there. I don't see its use, but it's good to know like how you can apply the binomial theorem to help you get like the tens place, ones place, hundreds place, thousands place. Break it up. Yeah, it's not that worst question, but it doesn't help that much either.